On September 12, 1962, U.S. President John F. Kennedy said these words:
"We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard."
Sometimes a similar principle comes up in game development. We do these things, not because they are easy, but because we thought they were going to be easy. This video is about one of those things. After the last devlog, I started working on the puzzle mechanics for my game. I had the idea for a gear that will function as a key to unlock a door. The gear can be picked up, put down, or kicked across the room. How long could it take to make? A few days? A week? What about... In case you're new here, I'm making a game that lets you rewind and accelerate time, as well as create clones of your past self that replay your previous actions. The gear I wanted to make was easy enough to get working when time wasn't being manipulated. Or at least easy enough to make compared to the nesting dolls of pain about to be opened. The first thing I tried to do was to get the picking up and putting down of the gear to work with rewind. This wasn't too hard to get mostly working, but for some reason the gear would always be slightly off from where it was supposed to be, and this would only get worse whenever time was rewound. Before going any further, you need to know a little bit more about how my rewind system works. It's helpful to think of the time system as analogous to a video editing software. I have a series of classes called timekeepers that are responsible for keeping track of data that changes almost every frame, like the position of an object or its velocity. You can think of this as the frames of a video. I have another class called timestack that is responsible for keeping track of important events that happen infrequently, such as when the gear is picked up or put down. You can think of these as markers on a video clip. Each game object records data individually, so it's like I'm recording a video of the player and a video of the gear, and then when I rewind I play both videos backwards at the same time. In theory, since both videos have the same timescale, they should be in sync with each other, but it appeared like the video of the gear was playing a couple of frames before or after the video of the player. Of course, appearances can be deceiving. But why investigate the root cause of an issue when instead you can spend hours coding an overcomplicated and error-prone system designed to mask the original issue? Once I had rewind working, I ran into my first time paradox. The player can pick up the gear, rewind, and create a clone of themselves. They can then rewind to a point before the clone exists and pick up the gear before their past self can. Because of the current way I had it coded, when the clone gets to the point where it is supposed to pick up the gear from the ground, it steals it from the player instead. This feels bad, so I added some checks so that your past self will only pick up the gear if the gear is roughly at the position your past self is expecting it to be, and the gear isn't already being held by the player or another clone. All this cost was a few extra generic parameters as well as my sanity. Until now, I had only tested rewinding when both the gear and Bob had the same timescale. But if the player rewinds while accelerating time, they will reach the point of picking up the gear before the gear has arrived, which because of the paradox code check I just added means that they don't pick up the gear. To fix this issue, I made it so that whenever the player attempts to pick up or put down the gear is set to the time that the player is expecting it to be. Unfortunately, this looks bad even though it works. In theory, I should be able to tell as soon as the player starts accelerating while rewinding that they are going to pick up the gear, and then accelerate the gear's timescale to match the player's, but before doing that I got distracted with yet another problem. I found that if the player collided with the gear and then created a clone of their past self, the gear wouldn't collide with the clone in the same way as the original. This is a big problem because of the code that avoids paradoxes. If you collide with the gear and then pick it up at its new position, the clone of your past self will collide with the gear in a different way and as a result not pick up the gear because it's not at the position your past self is expecting. My initial thought was to store the gear's rigid body properties like velocity at the moment of collision and then play it back when the clone collides with it in forward time. Unfortunately, Unity's physics aren't deterministic, which means that even if all the rigid body properties are the same, collisions can play out differently after rewinding. So this forced me to write a system that keeps track of clone collisions so that the exact same data can be replayed later. I now had a system that suspended the gear playing rewind data while you were holding it, a system that changed the current index of the gear's rewind data, and now a new system that stored previous gear rewind data and selectively overwrote the current rewind data with it. Needless to say, these systems did not cooperate well, and the bugs were multiplying faster than Bob. I needed a different approach. So I went back to the drawing board and tried to determine the root cause of Bob and the gear having different positions when rewinding. I printed out the current frame of rewind data above Bob and the gear and found that the difference between the two remained exactly the same both before and after rewinding, so the problem wasn't with the timelines getting out of sync. It turns out that the problem was caused by having the gear set as a child of Bob. When rewinding, the gear's transform would set its position, and then Bob's transform would set its position. But since the gear was the child of Bob, when Bob's transform set its position, it also changed the position of the gear. So in my transform timekeeper, I added some code that checks for any child-timed objects and unparents them before changing the position of the parent. it then reparents the child objects after. Now I have working rewind without an overly complicated system propping it up. Once I had that fixed, I was able to simplify the collision replay system a lot as well. Now the gear finally works forwards, backwards, fast backwards, slow backwards, forwards with clones, and backwards with clones. And all of that is why this one gear took me about a month to make. But it's been 2 months since the last devlog, so what did I spend the other month doing? If you're a returning viewer, you probably already noticed that I changed up the graphics a lot. Someone left a comment on the last video saying that I should try using a cell shader, which is something I've been wanting to experiment with for a while. I converted this great online shader tutorial to an amplify shader, and within a day I had working cell shading. Do you love this change? Hate it? Let me know in the comments. I also improved the way I was coloring the islands. Previously I was storing the color directly in the vertex color property of the island mesh, which means that if I wanted to change the color I had to completely regenerate the island from scratch. I changed it so things like the height map value and normal dot product are stored in the vertex color, and then wrote a simple shader to translate these values back into colors. This lets me try out different colors easily as well as having more fine-tuned control over the coloring of the islands. In the last devlog I announced that the game was going to be called Timeless Skies, but I got a lot of comments saying that it sounded a little too generic. I agreed, so I came up with a new name, Eyewinder. I asked my Discord server if Eyewinder was a better name than Timeless Skies, and the overwhelming majority agreed. I like this name a lot more than the old one too, so I don't anticipate changing it again anytime soon. I've also been working on a Tenet-like time inversion system, but it's not quite ready to show off in a video yet. Subscribe to avoid missing its unveiling in the next devlog.
Apple attack.